Bismillahirrahmanirrahim. My name is Muhammad Shoaib. Welcome back. Today in this tutorial video, we will learn what is a function like FC in the semantic manager and how we can configure FC in the semantic manager. Whether you are the beginner or just looking to refresh your skills, this guide will help you get started step by step. So the first thing is, what is a FC? In the semantic manager, a function or FC is a modular block of code used to perform a specific task without retaining state or the memory between the PLC scans. FC are a stateless, which means their internal variable reset every time the PLC execute. Means every scan cycle their variable is reset. They are a typical use for simple repetitive logic or calculation such as a mathematical operation or the logic comparisons where no long-term data storage is needed. So some of FC characteristic FC are the stateless executions. FC do not store or retain value between cycle. Each time an FC run, its internal variable are reset. For example, a, a function that calculates the sum of two numbers does not remember the sum in the next PLC scan cycle. Similar manner, the FC reusable logic. FC allow you encapsulate frequently used logic in a block which can called multiple time in the program like FBs. We can also call FC in the multiple time in the program language. FC no instance data blocks is required. Unlike the function block FBs, FC do not need an IDB instance data block since they do not store any data across a scan. This makes them lighter weight and efficient. Then the input and output parameters. FC can have an input output and input output parameter, allow flexible data exchange between the FC and the calling program. So when you can use the FC for the simple operation such as mathematical calculation, timer, or the basic comparison. When memory retention is not required across a PLC scan, to modularize logic that need to be reused in different place in the program. And we can also use for tasks like conversions, sensor check, or alarm evaluation. We can use these FCs. So the structure of the FC, the input parameter data pass into the FC like two numbers to we have to add. Okay, yeah, if we are using FC for the sum operations, and the output parameters output data return from the FC like the sum of two numbers. Input output parameter data pass in and modify by the FC like incrementing a value, and the temporary variables used within a FC but discard after the execution. So in the coming up tutorial video, we'll also use the temporary variables also and input and output parameters also. So let's see practically how we can configure FC in the semantic. So to configure FC in the Semantic Manager, just double click and open the Semantic Manager. So our setup wizard is open. Just click next. Select any of the CPU, up to you, and just click next. Okay, and just select the, for example, ladder language. Then select next and put the your project. For example, I will put the name of project underscore FC. Then click at finish. Okay, then come in the semantic 3 illustration, then double click over the hardware. So just expand semantic 300, then we'll select the interface module. Just drag and drop it here. And after that, we'll select first any DI module, any of the DI module we can select it. And then we'll select any AI module. Suppose any of the 14-bit module, I will select it. Okay, and that's it. Just save and compile. Okay, so you have to first thing ensure what is the addressing scheme. Like here, input address start from I0.0 and our analog input address start from PIW272. Just close it. Come in the blocks, right click, and then we'll create here the function. So select the function. So I will put the name scaling scale, and you can select any diagram. For this particular tutorial, I'm using the function block diagram, and then click OK and open the FC. So we will configure FC like as a scaling block. We will just give the input like raw value to our block, and engineering minimum, engineering maximum, raw minimum, and raw minimum, and it will give us the scaled value output. So for the scaling purpose, I will use this formula for the scaling purpose. So so first thing I have to like create variables. So for example, I will first create these variable here in the input interface. Just copy and paste just to reduce the video length, and I will put it real, and then the raw maximum, this will also I will select as a real, and then raw minimum, and the data type also real, then engineering maximum, this will also the real, and engineering minimum. This will also the real. Okay, so 5 variables. We configure it, and after that we'll configure the scaled value in the output, the scale data we need it in the output. We'll configure the real one, and I will also configure the some temporary variable also, that also I will configure as the real, the R2, then R3, R4, then R5. Okay, fine. And we'll also here one bit just for enable, that should be boolean. Okay, so mm, so as per our scaling formula, first raw value we have to subtract from the raw minimum. So I will take it like the floating, subtract, just double click it. So just drag and drop it. So I will first put it enable, and then I want to minus my raw value into raw minimum. So as you can see, raw value minus raw minimum. So result I will store in the R1. So now what is next? I also want to subtract engineering maximum minus engineering minimum. So I will again take the subtraction. So engineering maximum minus engineering minimum, and the result will be I will store in the R2. Okay, so what next? I want to multiply these both of the R1 and R2. So I will take the multiplier R1 multiply with R2. The result will be stored in the R3. Okay, I will insert a new line, or you can use it the same, anything you can do it. So until right now, that much part we already covered. Now before proceed for the next, we have to subtract raw value maximum into raw value minimum. So I will take the subtract block. So first I will enable, then the raw maximum minus raw minimum, raw maximum into raw minimum. So the result will store in R4. So raw maximum minus raw minimum result will store in the R4. So now what we have to do, we have to subtract like R3, we have to divide R3 with the R4. So to divide this function, I will take the divider. So R3 result will divide to R4 result, and I will store that result in the R5. Okay, so as you can see, the R3, this is the R3 output, and then this is R4, then R3 will divide with the R4 result. Now this all is the result will come in the R5. So I need one plus like addition block and engineering minimum plus the R5. So I need addition block. So R5 plus engineering minimum, and my output will be stored in the scaled value. So output store in the scaled value. So I will just recap, like raw value, we use the subtract block, raw value divided by minus by raw minimum. Then we also subtract engineering maximum minus engineering minimum. Then we multiply. We use the multiply block, like result of R1 and R2 will multiply, and then it will come in R3. Then we also use raw maximum minus raw minimum, and result will be in 4. Then the 3 and 4 we just divide it, and then after that result 5 we just add in the engineering minimum. So that's it. So I will just save it. Okay, then just close it, and we'll open the OB1. So I will, before calling you, I will enable my simulator, and I just want to verify the address. So my analog address, starting address is 272. As you can see, 272, PIW 272. So here should be 272. Okay, and this all data is coming in the integer. This PLC sim data. So we have to convert integer data into float data. So we'll take like integer, this integer to float converter, just drag and drop it here, and our input is PIW 272, and I will create some temporary variables here, and I will put AI1, and this will be the real. And here I will also create some level 1 temporary variable also. Um, you can create a DB block and you can just give it the reference of the global DB also. So global data block also. Just I'm using for the temporary purpose this temporary register. So I will put it here AI1. Okay, then I will insert. So here I just convert integer value into real, and after that I will call my FC block that just now I created, select and drag and drop it here. So here I will put AI like my integer value, AI like integer value converted into real, and this will also link as a raw value. Now raw value maximum is in my case 16363 for example, and you have to put it actually in the real format 0.0. Similar manner, engineering minimum 0.0 and engineering maximum, suppose 100 meter my tank level is there, I will put 100 engineering maximum, and engineering minimum 0.0. You can select the value as per your uh, sensor. Okay, and here I just put the enable button, and here I will put the level 1. That's it. Just save it. Okay, fine. So we will download this program in our controller. So in the controller, I will put in the run mode, select and just download the program. Yeah, so no, cancel. So as we are using the SM300 and we don't have the uh, TCP IP interface, so I will select the MPI and then just download the program. Okay. Do you want the start module? Yes. Okay, perfect. So now we'll go in the monitor mode or runtime mode. Okay, one thing I will do, representation, I will put in the float points. So as you can see here, right now my raw value is 0, in raw value maximum 16363, minimum 0, and engineering maximum 100, and the engineering minimum is 0. So first thing, I will enable my input on that, only that case my block will execute. So I enable my input 1.0. So now suppose I will put the maximum value 16363. Okay, so as you can see the result I receive 100%. Suppose if I will reduce like 16,000, so as you can see accordingly the my scaled output is also reduced. Suppose I will put the half 800. So as you can see accordingly the result is changed like 4000, and similar manner if I will put the 0 value, then the scaled output also 0. So that's it for today. So Alhamdulillah, we learn in this tutorial video what is a FC or functions, and how we can configure the FCs inside the semantic manager, and where we take the example of the scaling function. So that's it. Thanks for watching this video.